Good day, class. It's Sir Capistana again, and welcome back to another discussion here in Chem 21 Organic Chemistry. This is the part 2 of our second to the last lecture here in Chem 21, wherein for today we will be talking about amines, organic derivatives of ammonia. And to be exact, we will actually be talking about this three main topics regarding amines. We will be talking about their physical properties, preparations, and reactions. As you may have remembered in the past discussions, amines are just organic compounds uh, that are, we have their R groups that are bonded to ammonia. We have an ammonia, then nagkaroon lang tayo ng mga aliphatic groups or aromatic groups na kinonect natin dun sa ammonia na yun, replacing one of the hydrogens of our nitrogen. And in that, uh, we will be having these three parts of the discussion wherein we will be talking about their physical properties, preparation, and reactions. And in that, ito na yung magiging last part ng second lecture natin. So, let's talk about the physical properties of amines. And by physical properties of amines, we will be talking about their polarity, boiling point, and solubility. And as you may have remembered, meron tayong ammonia na nakabit dun sa ating sa ating amines. So, meaning to say, amines are generally polar compounds. By polar compounds, meron tayo bipolar compounds. It just means that we have a negative part and a positive part of our compound, meaning to say, kumbaga kung titingnan natin, if we have here our primary amines, wherein we have here our R and H2, yung magiging partially positive side ng ating itong polar compound natin ay itong nasa R group natin, and we will have a partially negative side, which is yung ating nasa N or yung nasa ammonia. So in case of tertiary, medyo nababawasan, tertiary amines, nababawasan yung tinatawag nating polarity ng ating amines due to the presence of three R groups that surrounds the the nitrogen. And in that, meron din tayong isa pang polarity na kailangan i-consider. Possible din yung H bonding sa ating amines. By H bonding, as you may have remembered, this is the bonding or the intermolecular forces in between other compounds na mayroong fluorine, oxygen, and nitrogen that is connected to uh, hydrogen. So in that, possible ang hydrogen bonding for primary and secondary amines. As for the tertiary amines, same concept regarding its polarity or being a polar compound, since due to the presence of three R groups surrounding our N, wala tayong magiging side for hydrogen bonding. Kaya mas nagiging possible yung hydrogen bonding with other compounds and themselves kapag nasa primary or secondary lamang yung classification natin ng ating amines. As for the boiling points, amines actually have higher boiling point than other non-polar compounds. So we have higher boiling point uh, th- than non-polar compounds. By non-polar compounds, we are actually talking about any other non-polar compounds na pwede nating maisip, mapa-organic man yan or inorganic. But in the case of other compounds like alcohols and carboxylic acids, mas mababa ang boiling points ng ating amine is in comparison with our alcohols and syempre yung ating mga carboxylic acid. So yun yung isang kailangan nating tandaan when we are dealing with boiling points in comparison with our alcohols and carboxylic acid. mas mababa yung boiling point ng ating amines. This is due to the presence of the OH. Dahil dun sa OH na yan or dun sa pagiging medyo partially malaki yung possibility na maging acidic yung ating alcohols and tsaka yung ating carboxylic acid being an acid, mas mababa yung boiling point ng ating amine which is a basic compound. And as for the solubility, all classes of amines are actually soluble in water. Mapa-primary man yan, secondary or tertiary man yung ating amines, they are actually soluble in water wherein we will have a borderline solubility up to 6 carbon atoms. Ibig sabihin amines or those amines na merong R group na ang carbon compounds or ang carbon atoms natin is greater than 6, medyo hindi na sila soluble sa ating water. Okay? So those are some of the notable properties of our amines. And as for that, let's go on to the preparations of amines. So by preparations of amines, paghihiwalayin natin ito kasi as you may have remembered, we have two types of amines. We have the aromatic amines and the aliphatic amines. So as for the aromatic amines, ito ay galing lang din class or yung aromatic amines natin actually ay nag-undergo lang nung nung free radical substitution ng nitrobenzene. So ano ba yung sinasabi kong free radical substitution ng ating benzene? As for that, let me just get my selection tool. Siyempre, mare-retain yung ating so from nitrobenzene, so by nitrobenzene that is yung ating merong benzene na merong NO2, okay? So our nitrobenzene, para ma-convert natin siya papuntang amines or isang aromatic amines, all we need to do is react this with concentrated hydrochloric acids in the presence of iron or selenium or tin pala. So by that, ang kailangan lang natin gawin, maglalagay lang tayo ng dalawang catalyst, mapa-iron man yan or yung ating ang SN nga ba 18? Later on. And also, we will be using our concentrated hydrochloric hydrochloric acid. And due to the presence of that hydrochloric acid, magkakaroon tayo ng hydrogen natin. And as you may notice here, just focusing on the white ones, kung mapapansin nyo, yung oxygen dito ay napalitan lang ng ating mga hydrogen, therefore having our aromatic amines. So kung gusto nating dagdagan pa yung ating R group dito sa scenario na ito, kailangan lang nating baguhin yung mga gagamitin nating reagent para lang magkaroon tayo ng secondary or tertiary amine. As for the aliphatic amines, ang kailangan lang natin dito, kailangan mo lang mag-start sa pinaka-reactive na hindi hydrocarbon. So by pinaka-reactive na non-hydrocarbon, ang may isip natin diyan na na compound ay actually yung ating mga RX, yung ating mga alkyl halides. So, from alkyl halides, dito tayo pwedeng makakuha or pwede tayo makapag-produce ng tinatawag nating aliphatic amines. All we need to do here is we just need to add our ammonia. Okay? So, by the addition of ammonia, we can actually produce our amines. So in production of primary amines, you just need an alkyl halide, then you just need to add your ammonia that will actually produce our NH2. Okay, so saan napunta yung hydrogen nating isa? It is actually bonded with our halogen here. So kapag gusto mo naman magkaroon ng secondary, na amine, all you need to do now is just to add another Rx. So, pag nag-add ka ulit ng Rx dyan, so let's say this is R2, right? So you will actually produce here your R2, and H. So, saan na naman napunta yung H? Sumama ulit siya sa ating halogen. And for the reaction of this with alkyl halide, ganun lang din mangyayari. So, if you add another R3 here, R3X, you will have here your tertiary amines having your R2, R3, N. So that is the preparation of our amines. Okay, so in that, we have there our preparation of amines. So as for the reactions, we actually, hey, I will be shortcutting some of the reactions here. We will actually be focusing only on the basicity of amines as nucleophiles and reactions with HONO or tinatawag nating nitrous acid. So for the basicity of amines, we will just be comparing kung gaano ba ka-basic or gaano kataas yung basicity ng ating amines. So, bakit nga ba natin may isip na basic ang amines? Because as you may have remembered, amines are just organic derivatives of what we call ammonia. And ammonia being a basic compound, you can assume na any derivative of ammonia will be uh, will be basic. Just like our organic derivatives of water, na pwede kasi nating i-treat ang water na isang acid, pwede rin siya i-treat na isang base, ay kasi neutral siya. But in any case, any derivative of water can actually be acidic times. So in that, ano yung relationship nito or ano yung mangyayari once na yung meron na tayong amines? As for the amines, ammonia is actually more basic than our aromatic amines. By aromatic amines, syempre andyan yung ating benzene ring, then andyan yung ating ammonia. So, sorry, that should only be two. Then and ammonia is actually less basic than our aliphatic amines. And as for the aliphatic amines, ito yung order ng basicity nila. Pinaka-basic yung ating tertiary amines. Kasunod doon yung ating secondary amine. And pinaka-least basic yung ating primary amines or aliphatic amines. Okay? So ano kaya yung ano nito? Ano kaya yung concept behind dito? So kung aanuhin nyo class, kung isipin nyo kasi class, ang basicity actually ay nakadepende sa stability ng tinatawag natin na cations. So by stability of cations, kapag ang isang pag tinreat mo na living group, yung ating ammonia or yung kumbaga yung ating NH or yung nitrogen natin dyan sa ating mga amines, kapag mas may stabilize natin yung presence ng tinatawag natin na cation or yung mga positive ions, mas nagiging basic ang isang compound. So basically dahil doon, kung titingnan nyo rito, yung R group kasi natin actually can be considered as a stable cation. And dahil dun sa stability ng cation na yun, mas nagiging basic yung ating mga aliphatic amines kaysa ron sa ating aromatic amines. So bakit mas nagiging basic yung aliphatic amines kaysa sa aromatic amines? Kasi may tendency kasi yung ating mga aromatics na stabilize yung buong ring towards dun sa kung ano yung dinidictate ng ating mga tawag dito, ng ating mga substituents. And nitrogen or yung ating NH2 being an electron releasing group, may tendency yan na hindi ma-stabilize yung ating cation. So kumbaga, kung magkaroon ka rito ng positive charge dito sa side na ito, ang tendency ng nitrogen natin ay mag-release siya ng, tawag dito, ng electrons towards dun sa ring. Dahil doon, hindi nagiging stable yung cation natin. So, mas nagiging less basic siya. Hindi katulad nitong sa ating mga ano, sa ating, tawag dito, sa ating aliphatic amines, ah, hindi ganon yung nagiging effect ng ating ammonia or ng ating NH2 dun sa R group natin. Mas nagiging stable yung pagiging positive no or pagiging cation ng R group natin when in comparison with our aromatic amines. So kung iisipin niyo yun kung bakit ganito yung order of basicity dito sa ating tertiary, secondary at primary amines kasi yung kung iisipin niyo kung pare-parehas yung R group na nandyan, pare-parehas sila ng sizes, mas marami yung R groups na pwedeng maging stabilized na cation doon sa ating doon sa ating R groups dito sa ating tertiary kaysa sa secondary. Kasi kung titingnan natin yung degree, 3 times na mas madami yung cations or yung pwedeng maging stabilized na cations dito sa ating primary kaysa ron sa doon sa ating tertiary kaysa ron sa primary nating aliphatic amines. Therefore, mas nagiging basic yung ating R3 or yung ating tertiary amines kaysa ron sa ating secondary amines at saka sa primary amines natin. So, may ganong effect din na nangyayari dun sa ating mga aromatic groups. So, anong sinasabi kong effect na yon? So, minsan kasi may tendency tayo na magkaroon ng tinatawag nating iba pang substituents ng ating benzene ring ay doon sa ating ng benzene ring doon sa ating aromatic amine. Kung maalala nyo yung tinatawag nating electrophilic aromatic substitution. So basically, kapag nagkaroon tayo ng disubstitution dun sa aromatic amines natin, so ano ba yung sinasabi kong disubstitution? So halimbawa, kukunin natin tong ating, itong ating, so let's say that we have here our aromatic amines, and due to the process of what we call electrophilic aromatic substitution, nagkaroon tayo ng isa pang group. Baguhin natin yung kulay ng group na yan. Let's say, meron tayong panibagong group na napabond dyan sa ating benzene ring na yan. So, nakadepende dun sa property ng group na yan kung ano yung magiging basicity nitong ating aromatic amines. So, kumbaga, kung yung group natin, halimbawa, ay dalawa sila. Ha? Let's say we have here this group. So, yung isang group natin, let's say ay mga electron releasing groups. So by electron releasing groups, may tendency silang magbigay ng electrons dun sa benzene ring natin. Tapos meron naman tayong isa pang group dito na electron withdrawing groups. So ano ba yung mga electron releasing groups na yan? Pwede dyan ang ating NH2. Pwede dyan ang ating OCH or yung ating mga alkoxides. Then, pwede rin yung ating mga R groups. Okay? Doon naman sa ating mga electron withdrawing groups, pwede dito yung ating NO2. Okay? Nitroso. Pwede rin dyan yung ating SO2, yung ating sulfuric. SO3 pala. Tapos pwede rin dyan yung ating carboxylic acid or yung ating acyl group. And pwede rin dyan yung ating mga halogens. Okay? So, yan yung dalawang groups na pwede natin tingnan. Yung isang group, ito yung tinatawag natin electron releasing. Yung ating spelling. Yung isa ay yung ating electron releasing. And yung isa naman ay yung ating electron withdrawing. Shortcut ko na lang ha. Okay. So, ano yung magiging effect nito? Ano yung magiging effect nung pagkakaroon ng electron releasing at electron withdrawing groups dun sa ating mga aromatic compounds? So, for those electron releasing, ang mangyayari dyan, mas makakapagbigay siya ng electrons towards the benzene ring. Kaya ang nangyayari dito dun gaya dun sa sinasabi ko kanina, hindi nagiging stable yung presence ng tinatawag nating cation or yung positive ion. So, pag meron tayong substituted na aromatic amine na meron ka pang isa pang NH2 o kaya OCH o kaya R group na attached dun sa benzene ring mo, ang nangyayari, less acidic yung ating electron releasing groups kesa dun sa ating electron withdrawing group. Okay? So, kumbaga, ito, itong electron withdrawing groups, mas ginagawa nilang basic yung ating aromatic amines at para naman dun sa electron releasing, binababa niya naman yung ating basicity. Okay? So, yun yung baliktad niya. Ang nangyayari pala ay, ayun, sorry about that. Yung ating electron withdrawing, dahil wini-withdraw niya yung electron to mula dun sa benzene ring natin, nagiging destabilize yung ating cation dito sa loob. Kaya ang nangyayari, bumababa yung basicity ng ating compound dyan. At dito naman, dahil meron tayong electron releasing, mas nagiging cation yung benzene ring natin, mas tumataas naman yung kanyang basicity. Okay? So that is the basicity of our amines, mapa-aliphatic amines man siya or aromatic amines. Okay? So in that, let's go to another reaction of our amines, wherein we will looking into amines as nucleophile. So we have here two reactions of amines. One is its reaction with alkyl halides. So in this reaction, actually ito ay pinakita na natin kanina sa preparation ng ating amines. So if you have your amine here, say we have here our R and H2, then you added or reacted this with your RX. What will happen here is you will have a secondary amine wherein you will have your R, you will have your R na galing dun sa RX, then we will have here our NH. Okay? Plus, siyempre, yung ating H, saka yung ating Zen. So, kung meron ka namang ganun din, kung meron kang secondary amine, at you reacted this with your RX, ganun lang din yung mangyayari. You will actually be producing a tertiary amine wherein you have your R there and you have your R2. Ito yung R na galing dun sa ating alkyl halide. And then we will have here our nitrogen. Saan napunta yung hydrogen? Andun siya kasama ng ating halogen. So, baka nag-iisip kayo, sir, ay di wala na namang reaction yung tertiary. Actually, meron. So, for our tertiary amines, if we react this tertiary amines with our alkyl halide or our RX, what will happen here is we will have here our R3. Then, we will have here our, not R3, tama, R3 nga, plus yung ating R, na galing dun sa ating alkyl halide. Then, we will have here our nitrogen with a positive charge. So, bakit nagiging positive charge yun? Dahil yun dun sa nabawasan siya ng electrons for bonding dun sa R group natin na nanggaling dun sa ating alkyl halide. Okay? So, that is one of the reactions of amines as nucleophile. Hindi ko na ipapakita mismo yung reaction mechanism. In any case, Another reaction of amines is its conversion into amides. So as you may have remembered, amides are actually another functional group here in our discussion in organic chemistry. So kung mapapansin nyo, wala akong sinasabi na magkakaroon tayo ng discussion regarding sa amides, but ito yung isa sa mga reactions na pwede nating tingnan wherein we actually have here our nucleophilic acyl substitution na actually related dun sa discussion natin sa mga acyl substitution dati nung pinag-usapan natin yung carboxylic acid. So, in here, we actually have here the conversions of amines to amides, wherein we will actually be just adding our acyl compounds here. We have here an acyl halide, and also we have here an acyl sulfamide. So, pero yung acyl sulfamide natin dito, siya actually ay aromatic. May aromatic ring tayo dyan. So, ano ba yung nangyayari sa reaction na to? Basically, ang nangyayari lang dito, yung, ano natin, yung, dito, mula dito sa amines natin, yung amines na yan, ma-abstract or matatanggal yung isang hydrogen dyan, and then it will actually replace our chlorine here. Kasi stronger nucleophile yung ating amine kesa ron sa ating chlorine dyan. So, ano ang mangyayari dito? So, basically, all you need to do here ay, ang nangyayari lang dito, itong buong acyl na to, ma-abstract lang yung ating chlorine. By ma-abstract, matatanggal lang yung chlorine natin. Hindi natanggal yung C. In any case, ganun lang siya. Tanggalin lang natin yung C na yan. Tapos, ang mangyayari, mababawasan lang yung hydrogen natin dito. And we will have here our R, ay, no, NH. We're gonna have here our NHR. So, saan galing tong NHR na yan? Galing yan dito sa ating primary. Okay? So, same reaction will happen here in our sulfamide here. So, ang mangyayari lang, ma-abstract lang ulit yung chlorine or pag ma-abstract, matatanggal lang yung chlorine. Tapos, we will have here our NHR na galing lang din dito sa ating primary. So, ganun lang din when it comes to our secondary amines. Ganun lang ulit yung gagawin nyo. All we need to do here is just copy this. Then we just need to replace that chlorine with our NR2. Ay, saan napunta ulit yung nitrogen? Kasama na ng chlorine. At in any case, ganun din dito sa ating sulfamide. So, for our sulfamide, you just need to add there your NR2. Okay? So, yan ang reactions ng ating amines or secondary amines with our acyl halide or yung ating acyl chloride and dun sa ating sulfamide. Okay? And in here, para dun sa tertiary, walaan nyo nga kung ano yung magiging reactions natin dito. Pwede nyo i-pause mo na yung video. Okay. So the answer here actually is NR. By NR, this is not, hindi siya acyl compound yan. By NR, ang ibig natin sabihin dyan ay no reaction. Okay? Bakit no reaction? Kung mapapansin nyo kasi, wala tayong i-abstract na hydrogen dun sa ating tertiary amine. So, walang mangyayari, hindi mag-a-act as nucleophile yung ating tertiary amine. Okay? So, those are the conversions of our amines into amides. Okay? So, for our last reaction, we have here the reactions of amines with HONO or yung tinatawag nating nitrous oxide. So, as you may see here, again, wala na naman tayong reaction with nung amines natin, nung tertiary amines natin, simply because ang nangyayaring reaction naman dito ay electrophilic. Uh, Substitution. So dahil dun sa case na yon, hindi tayo magkakaroon ng reaction dun sa ating dun sa ating tertiary amines kasi wala na naman tayong sites for reaction kasi wala yung hydrogen natin doon. But in any case, for these reactions, we have here the primary amines, secondary amines. Then we have here our aromatic amines. So we have the primary aromatic amines, the secondary aromatic amine, and the tertiary aromatic amines with their reactions with HONO. So what will happen here for the reactions of HONO is for initial reactions of primary amines into HONO, we will actually have this product ganito. So we will have here our R group, our nitrogen. Then we will actually have here a double bond, a triple bond with nitrogen, bearing a positive charge on our amine nitrogen. So dahil dyan, we can actually let this proceed with another reaction na kapag nag-add tayo ng water, what will happen here is we will have this mixture of products. We will have nitrogen gas, so plus a mixture of some ROH, and also we will also have some alkenes na galing din sa R group. Okay? And for this the reaction of HONO with our our secondary amine, what will happen here is we will have here our R2, then that is bonded to our nitrogen. Then we will have here a bond with our nitrogen from the HONO, which is actually the double bonded to our oxygen. This is what we call our N-nitroso amine. Why nitroso? We have here nitroso, itong itong white na ito, and yung amine natin ay itong part na ito. So, pwede kong palitan yung kulay ng amine so para mas makita nyo kung nasaan kung alin yung nitroso at alin yung amine. Okay? Okay? So in here, we have here this reactions of aromatic amines with HONO. So this will be the products of this reaction. So we'll just be taking this. And due to the presence of the HONO, parang yung sa primary amine lang natin, we will have here a compound na ganito yung itsura. This is actually an special cation. This is what we call diisonium cation. And for the secondary amine, ganun lang din ulit, parang yung sa reaction natin dito earlier. So we have here this formation of N-nitrosamine. So ganun lang din yung mangyayari dito sa secondary natin. So dyan sa secondary aromatic amine natin, we will just be cleaving our nitrogen atom here. So mangyayari, we will still retain our aromatic amine here, or our secondary aromatic amine here. So we will just be connecting or attaching or bonding our nitroso here. So this is what we call, again, this is just N-nitroso amine. And for this case, yung amine natin dyan is just an aromatic amine. Okay? And for the last one, with the reaction of Hono, the dito sa ating compound na ito, we will actually be experiencing what we call electrophilic aromatic substitution here. Kasi ang mangyayari, ay ganito. Instead na dun sa ating amine magko-connect or magkakaroon ng bonding, what will happen here is we will actually have here a P uh, nitroso. So we have here P nitroso. P nitroso tertiary amine. Okay? So yan yung mga reactions natin with amines. So konting review lang. So balikan lang natin at medyo nag-die down yung energy ko sa kalagitnaan ng discussions natin. But basically, we have here, we first discussed the basicity of amines, wherein we look into the comparisons of basicity of our aliphatic amines, ammonia, and yung aromatic amines natin. And in that, we actually discussed that uh, aliphatic amines are more as basic than our ammonia and our aromatic amines. And as for the aliphatic amines, we have here this arrangement or order of basicity. The most basic is our tertiary, next is our secondary, and next is our tertiary. So, as for aromatic amines, nagbabago-bago rin yung basicities ng ating amines. Nakadepende kung siya ba ay disubstituted. So, kung meron tayong iba pang substituents na naka-attach sa benzene ring natin, nakadepende doon kung ano yung magiging basicity ng ating aromatic amines na yun. So, kapag meron tayong electron releasing na group like another amine or yung alkoxides natin or R groups that is attached to our aromatic amines which are electron releasing, dahil dun sa additional na electrons na meron tayo, nagkakaroon tayo ng mas nagiging stable yung tinatawag nating basicity ng ating aromatic rings. Therefore, mas nagiging basic siya. And as for our electron withdrawing groups like our nitroso or yung NO2 natin, yung ating sulfuro, yung ating SO3, yung ating acyl compounds at saka yung ating mga halides, ito naman yung mga tinatawag nating electron withdrawing groups at dahil nag-withdraw tayo ng electrons, hindi na-stabilize yung cation. Therefore, dahil na-destabilize yung ating cation, nababawasan yung basicity ng ating aromatic amine. Also, we have here this reactions of amines with nucleophile. We are just replacing our uh, our hydrogens with the R group na present dun sa ating alkyl halide. So this is amines in reacting as a nucleophile na pinare-react natin siya sa ating alkyl halide. Also, we have here the conversion of amines into amides. So we have here, we concluded here that there are no reactions or the conversion of amines to amides. Okay? So dahil wala tayong site kung saan natin pwedeng mag-act as nucleophile yung ating amines. And also, we are just replacing the chlorine or the halide dun sa ating acyl compound or dun sa ating sulfonyl. Okay? So, also, we have here the reactions of amines with nitrous acids. So, para dun sa primary, nagkakaroon tayo ng triple bonds and we will be having a cation dun sa ating nitrogen atom ng ating amine. And for secondary, nagkakaroon tayong addition of nitroso wherein for mapa dun sa aromatic or sa aliphatic amines natin, yung nitroso natin it is actually bonded to our amine nitrogen. And also for tertiary aromatic amines, pwede tayo magkaroon ng electrophilic aromatic substitutions due to the presence of HONO, wherein we will have a product na majority ay P-nitroso. Okay? So those are the reactions of amines. And for today we actually finished three main concepts for amines. We talked about their physical properties. Okay? We talked about their preparation and we also talked about their reactions. Okay? So in that, I will be ending this lesson here. So if you have any questions regarding this topic, dahil medyo ayan, medyo mahaba-haba yung naging topic natin dito. So, pwede kayong mag-chat na lang sa akin. You can chat me on my Facebook account or you can send me a message. Okay? So, thank you and have a great day ahead, class. Bye-bye.